Hi, welcome to Introduction to Water Quality. I'm Andrea Kealoha. So why do we care about water and why do we measure water quality? First, 70% of the earth is covered in water. Most of our oceans cover earth. So if you were to look at earth from outer space, you would see that earth is blue with a little bit of green. Water also helps to moderate the climate. So our ocean currents are constantly circling across the globe. And they're moving warm water towards from the equator towards the poles, so that the poles don't get colder and colder. And then the ocean currents are moving cold water from the poles to the equator, so that the equator doesn't continue to get more and more hot and eventually boil over. Living things could also not survive with water. So scientists that are looking for life on other planets, the first thing that they look for is water, because we know that life as we know it needs water to exist. Also, our bodies are made up of 72% water, and most living organisms also are composed of some portion of water. For example, jellyfish are mostly composed of water, something like 95 to 99%. Most of our water on Earth is in the ocean, so about 96.5%, but a small portion of our water on Earth exists as freshwater in lakes, rivers, streams, and in groundwater. Some of it exists in its solid form, in ice caps, glaciers, and snow. And then a very small percent of Earth's water exists as gas or water vapor in the atmosphere. The water cycle is a continuous movement of water through Earth's different spheres. So the atmosphere, the Earth, and the ocean. So we have evaporation from the oceans, moving water into the atmosphere. That water condenses to form clouds and eventually travels higher up into the atmosphere. The water condenses and eventually precipitates as rain or snow. And then that water forms rivers or lakes or streams. Some of it goes into the ground to form groundwater, and then eventually that river or that water makes its way back into the ocean. So water is continuously moving from the ocean to the atmosphere and to our Earth. The issue with the water cycle is that human activities pollute the water. So for example, we like to build homes and buildings near streams, but a lot of our pollution or domestic wastewater makes its way into the groundwater, into the streams. Industrial activities are often located near rivers or streams, and then agriculture often is built near rivers. So our plants need water to survive, but we often fertilize those plants with nutrients, and then those fertilizers or those nutrients make its way into the streams and eventually into the ocean to pollute the ocean. A watershed is a land area that channels rain into streams and rivers that eventually reaches a large water reservoir, which in our case in Hawaii is the ocean. So our watersheds are bounded by two mountains with a valley in the middle. So the rain often occurs up in the mountains, and then all of that water forms rivers and streams that make its way into the valley and then out into the ocean. So when we think about water quality in an area, we have to understand all of the different activities that are occurring in our watershed that could contribute to the quality of our water. So Kaehu Bay is labeled in this little bay area, and to the south of Kaehu is Kahalui Harbor. Kaehu is located within the Ia watershed, And the major stream or river in the Iao watershed is the Iao River. It's also, Ka'ehu Bay is also bounded by the Wai'ehu stream. So Ka'ehu is bounded by both, or is influenced by the watersheds of Ka'ehu, or of Wai'ehu and of Iao. And so the quality of the water in Ka'ehu Bay is affected by the activities in both these watersheds. Wetlands are transitional areas between land and aquatic systems. In Hawaii, most of our wetlands are located near the ocean, and so they have mid-salinity ranges. They're influenced by both fresh water and seawater, especially at the high tides. When seawater comes up and influences the wetlands, the salinity of these wetlands can increase. Wetlands are important habitats for many different types of organisms, including birds or fish like o'opu. In early Hawaii, wetlands were important for the cultivation of crops such as taro. With the migration of early immigrants, wetlands were used for cultivation of rice or watercress, and then eventually these wetlands were cleared for the cultivation of sugarcane. So we've had a lot of loss of our wetlands due to agricultural activities, but also urban development. More recently, we're starting to build houses on wetlands, hotels, or golf courses. Wetlands are natural filters for sediment and pollution. So all of the rivers and streams that flow through watersheds and collect pollutants on the way towards the ocean, the wetlands help to filter out these pollutants. So if we lose the wetlands and there's no filter for the pollutants, then all of those pollutants make their way into the ocean. Some of the most prominent wetlands on Maui are Ka'ehu, Kealoha, and Kanaha.
So there's 6 major water quality parameters that we measure. The first is temperature, salinity, oxygen, pH, nutrients, and turbidity. By measuring all of those water quality parameters, we can kind of make inferences about the health of the ocean ecosystem in that area.
For temperature, we use the units degrees Celsius. You're probably more familiar with degrees Fahrenheit because that's what we get our atmospheric temperature. That's how we measure our atmospheric temperature or our body temperature. But degrees Celsius is a part of the metric system, which is used across the world. So if we want to compare our temperature measurements to the measurements of other scientists, we need to use the unit Celsius. Temperature is important because it determines the kinds of organisms that live in the environment. So these organisms have adapted to specific temperature ranges. If the water gets too warm, for example, corals will start to bleach. They'll show signs of stress. Same thing if the water gets too cold. But a little bit warm, if the water gets just a little bit warmer, it can be good because warmer temperatures facilitate biological reactions such as speciation, feeding, and reproduction. We just don't want the water to get too hot. Salinity measures the dissolved salts in water, and most of these salts exist as sodium or chloride, which is just the salt that we have on our dinner table. But there are other types of salts in seawater, including potassium or magnesium. Freshwater has low salinity, so a salinity of 0, and seawater has a higher salinity of about 35. Wetlands, because they are composed of brackish water, or a little bit of salt water and a little bit of fresh water, they have mid-salinity values, anywhere from 5 or 10 to 25 or 30. Similar to temperature, organisms have adapted to live in specific salinity ranges, and so if the salinity changes too much, these organisms have to leave the area, or they can show signs of stress or even mortality. For example, we don't often see corals located near the mouths of rivers because corals have adapted to higher salinity ranges of the ocean, and so they can't live near rivers that are dumping out very low salinity water. Nutrients are also an important water quality parameter, and the two most important nutrients are nitrogen and phosphorus. So nutrients are important for photosynthesis, which is performed by our plants like algae or limu. So a little bit of nutrients is good, but too much nutrients in an aquatic system or in an oceanic system is bad. So excess nutrients enter into our water systems through fertilizers, sewage, or runoff. And the wetlands are there to help filter out these excess nutrients before they make their way into the ocean. But the problem is that we're losing a lot of our wetlands. Excess nutrients can lead to algae blooms, and when those algae die, they consume oxygen, leading to low oxygen in the water column. And oxygen is required for life. So oxygen typically enters the water from the atmosphere. So our atmosphere has a lot of oxygen, and then that is taken up by the ocean. Organisms in the water breathe dissolved oxygen. So for example, fish use their gills to bring in water, and then their gills remove the dissolved oxygen from that water and then release the excess water. If the oxygen gets too low because we've had too much nutrients and algae blooms, then mortality can occur. So this figure is showing when you have high concentrations of oxygen, 9 or 10, the water can support abundant fish populations. But as the oxygen concentration of that water declines, the water supports less and less fish until you get to about 4 parts per million, and the water can no longer support aquatic life. Turbidity measures the cloudiness or the dirtiness of the water. That dirtiness is usually caused by sediment or soil that is disturbed. For example, if your rivers are running really strong, then all of the sediment gets kicked up from the bottom of the riverbed, or if there's a lot of waves in the shoreline, that sediment is kicked up by the waves, causing higher turbidity of the water. When you have really turbid water, all of that sediment can block sunlight, which is needed for photosynthesis of our aquatic plants. Sediment, when it settles, can also smother organisms that live on the bottom. So the figure on the bottom right, the dirtier water has high turbidity, and the very clean water has low turbidity or very little sediment. pH determines whether a substance is acidic or alkaline or basic, and the pH scale ranges from 0 to 14, with 0 being the most acidic and 14 being most alkaline or basic. Optimal pH for aquatic organisms is somewhere between 7 and 9. So for example, drinking water or fresh water has a pH of about 7, and seawater is slightly alkaline with a pH of about 8. Similar to temperature and salinity, aquatic organisms have adapted to specific pH ranges, and so if the pH of the water changes too much, it's very stressful for these organisms. Okay, and one other thing that we measure or we record when we're performing water quality is latitude and longitude, because it gives us our position, and we need to know the position that we took those measurements in case we ever want to go back to that location to measure the water quality again. So lines of latitude run parallel to the equator. They're equally spaced, and they tell us whether we are in the northern or the southern hemisphere. Lines of longitude run perpendicular to the equator, and they tell us whether we are in the Western or the Eastern hemisphere. This is a map. So equator is at 0, and this red box is showing the location of Hawaii. So the latitude of Hawaii is 20 degrees north, and the longitude of Hawaii is 158 degrees west.
So he leo mahalo kia ia o ko pakahia pau no ka hui ana no ka ho'ona nea pu ana me mākou no ka ho'oka ike no ka ho'olohe ana I ka ike Hawaii o kia makumu. Mahalo nui for all of you tuning in with us throughout these past days and really, engaging in the ike that has been shared from all these wonderful mentor and kumu of Maui, of Hawaii. He leo mahalo keia, again, mahalo to Ka'ehu, again, mahalo to all the people who shared and engaged with us in our keiki and our community. And again, this is encouragement to all you folks to find that space in your own community to learn, to engage, to share, to create relationships with Aina and with people and learn more and share more in the culture in the Aina, and I'm so happy to be able to share with you folks today and throughout these past days. So mahalo piha ia o ko pakahia pau o wauno o ka hakuriti kamara ma ka ehu a hui ho launa pu ho kako I ke kahila a hui ho.